The cosmos is filled with truths that sound more like fiction than reality, yet they are entirely real. This audiobook will guide you on a 2-hour expedition into a universe teeming with marvels. From impossible planets and silently exploding stars to phenomena that our science is just starting to grasp. As you listen and relax, your imagination will venture further than ever before, delving into stories that appear unbelievable until you accept that they are unfolding at this very moment, far beyond our world. Our species has an unquenchable thirst for knowledge. Since the dawn of humanity, we have stared at the night sky, wondering what exists beyond the thin veil of our atmosphere. The universe, in all its immense complexity, is not just an object of fascination. It is a grand stage for the cosmic dramas of creation and destruction. Every star you see is a messenger from the past, a silent witness to events that transpired thousands or even millions of years before their light reached you. The sheer scale of the cosmos is almost impossible for the human mind to process. Consider the ocean. On the surface, it appears to be a vast, uniform body of water, but beneath it lies a hidden world of currents, life, and mysteries we are only now beginning to chart. In the same way, the universe is brimming with extraordinary occurrences that defy our everyday understanding, from the birth of stars in glowing nebulae to the cataclysmic mergers of entire galaxies. So, what actually occupies the expanse of space? A simple answer might be that it is an empty void. But this barely scratches the surface. Space is actually filled with gas, interstellar dust, powerful radiation, and the gravitational forces that sculpt the very fabric of reality. If you could journey through the cosmos, you would find that every star, planet, and black hole is a single component in a colossal puzzle that stretches far beyond the limits of our imagination. Exploring the universe doesn't just give us answers. It inspires a cascade of new questions. Why do certain stars burn steadily for billions of years, while others perish in a brilliant, fleeting explosion? What unseen forces govern the formation of galaxies? And how are these immense structures woven together across the cosmic web? These inquiries propel us forward on a thrilling quest, where each new piece of knowledge unlocks a doorway to even greater mysteries. On this expedition, it's vital to recognize that you are a small yet integral part of this immense cosmos. The very atoms that constitute your body were forged in the fiery hearts of ancient stars, meaning you are fundamentally connected to everything that surrounds us. Gazing up at a clear night sky serves as a powerful reminder that we are not isolated. We belong to something immeasurably larger than ourselves, a cosmic symphony where every element, from orbiting planets to galactic clusters, plays a vital role. Through this audiobook, I want to invite you to accompany me on this grand tour of discovery. Together, we will use the tools of science, curiosity, and imagination to confront phenomena that will test our logic and ignite our desire to learn more. We are about to uncover some of the most profound wonders the universe has in store, venturing toward new horizons where stars shine with unique brilliance and planets perform their orbital ballets. Our itinerary will take us into the shadows of black holes, to the shores of distant galaxies, and through the enigmatic realm of dark matter, the invisible substance that constitutes most of our universe. We will trace the complete life cycle of stars, from their spectacular birth in stellar nurseries to their explosive deaths, and see how these powerful events continuously reshape the cosmos. This pursuit of understanding is a journey without an end, where every discovery only deepens the mystery. This exploration is not just about observing the universe's magnificence, but also about reflecting on our own place within it. To comprehend the cosmos is to be awed by its beauty, and to acknowledge the delicate nature of our own existence. In the vastness of space, each life is but a momentary flash of light. Yet every one of those sparks is an essential part of this extraordinary and interconnected whole. So, let us begin our dive into the wonders that await. Within the immense cosmic ocean, a truly captivating process gives rise to stars. The formation within nebulae. These colossal clouds of gas and dust act like celestial sculptors, crafting the luminous spheres that illuminate our skies. This spectacular creation is the result of an intricate interplay between gravity and matter. Nebulae consist mainly of hydrogen, which is the most basic and plentiful element found throughout the universe. The process begins as particles within these cold, dense clouds start to clump together, a crucial first step towards stellar birth. As these pockets of gas and dust grow denser, gravity begins to assert its dominance, pulling more material inward. The escalating accumulation of matter causes both the pressure and the temperature at the core to rise dramatically. You can think of it like compressing a snowball in your hands. The more you squeeze, the more compact and dense it becomes. This gravitational collapse is the engine that generates the immense heat required for a new star to finally ignite. Once the temperature inside the core of a protostar reaches millions of degrees, the transformative process of nuclear fusion is triggered. At this point, hydrogen nuclei are forced together to create helium, releasing a tremendous amount of energy in the form of light and heat. This outpouring of energy is what allows the star to shine brightly and maintain its stable existence for millions or even billions of years. However, a star's life is not limitless, and as it steadily burns through its hydrogen fuel, it inevitably begins a slow transformation toward its end. Those brilliant points of light you see in the night sky lead extraordinary lives, far more complex than their simple appearance suggests. Have you ever considered how a star is born? The entire life cycle of a star, from its formation within immense clouds of gas and dust to its ultimate demise, is a truly epic narrative filled with incredible drama and transformation. The journey of a star originates inside what astronomers call a nebula, which is an enormous cloud composed of hydrogen, helium, and other cosmic materials. It is within these stellar nurseries that the perfect conditions arise for a kind of cosmic magic to occur. But what exactly prompts a nebula to transform into a star? The key is gravity, the fundamental force that relentlessly pulls all matter toward itself, initiating the captivating process of stellar birth as it gathers gas and dust into a dense core. As the pressure within this collapsing cloud reaches a critical threshold, the core becomes hot enough for hydrogen atoms to begin fusing into helium. This process, known as thermonuclear fusion, unleashes a tremendous amount of energy and signifies the true beginning of a star's life. With its fusion engine ignited, a young, bright, and intensely hot star starts to shine, illuminating its corner of the cosmos. It's astounding to realize that this very same process is powering billions of other stars throughout the universe, including our own sun. Following their birth, stars settle into various stages of life. For a star similar to our sun, this stable period lasts for about 10 billion years. Throughout this long existence, it maintains a delicate balance between the inward pull of gravity seeking to crush it and the outward pressure generated by the fusion in its core. Yet what happens when its primary fuel source eventually runs dry? It is at this point that the star's story takes an even more fascinating turn. Once a star has depleted the hydrogen in its core, it transitions into a new phase of its evolution, expanding dramatically to become a red giant. You can picture it like a bubble inflating to its maximum possible size. In this massively enlarged state, the star is capable of engulfing any planets orbiting too closely, which, in our solar system's distant future, could include Mercury and Venus. This, however, is not the end, but simply another profound transformation in its long life. After its time as a red giant, a star like our Sun will cast off its outer layers, creating a breathtaking celestial object known as a planetary nebula. This event is a spectacle of vibrant light and color, representing the final legacy that many stars leave behind. At the center of this expanding shell of gas remains a white dwarf, an incredibly dense and hot stellar remnant that will gradually cool and fade over the course of billions of years. Not all stars, however, share this relatively peaceful fate. Those that are significantly more massive than our Sun are destined for a far more violent end. They conclude their lives as supernovae, colossal explosions that, for a short time, can radiate more light than an entire galaxy. Can you even begin to fathom the sheer scale of witnessing such a cosmic spectacle? Supernovae are much more than just blinding displays of light. They are fundamentally important for the creation of new elements. When these massive stars explode, they scatter heavy materials like carbon, oxygen, and iron far out into space. This process seeds the next generation of stars and planets with the essential building blocks for life. In this way, the death of a star can become the catalyst for the emergence of new worlds and new life. As stars are born, live out their lives, and eventually die, they continuously shape their cosmic surroundings. The shock waves from a supernova can trigger the collapse of nearby gas clouds, initiating the formation of new nebulae where matter once again gathers to give birth to stars. This grand cycle of life, death, and rebirth repeats itself over billions of years, driving the constant evolution of a dynamic and ever-changing universe. Stars are also frequently part of larger systems, sharing their cosmic neighborhood with other celestial bodies. These complex interactions can lead to phenomena like gravitational capture, where one star's immense pull can draw another into its orbit. This intricate cosmic dance serves as a powerful reminder that nothing in the universe truly exists in isolation. Instead, all stars are connected in a grand tapestry, woven together by the force of gravity. When you look up at the night sky, you might be tempted to see each star as a solitary, unchanging point of light. But the truth is that every single one of those stars holds a story. Each has embarked on a unique journey, complete with its own history of creation, its own struggles, and its own ultimate transformation. This endless cycle is what shapes the very fabric of the cosmos, and every star you see is a testament to this powerful process. So, the next time you gaze upon the starry expanse, I want you to remember that each of those brilliant lights is the culmination of millions of years of cosmic history. From the cataclysm of a supernova to the delicate formation of a new nebula, the universe is filled with wonders that are always inviting us to explore further. Each star is like a page in the great book of the cosmos, and everyone has its own unique story to share. Some stars are vibrant and youthful, while others are in their final stages, leaving behind streams of elemental material that will seed generations to come. Exploring the life cycle of these celestial bodies not only deepens our comprehension of the cosmos, but also forges a profound connection to our own being. Fundamentally, the very atoms composing your body were forged inside the hearts of ancient stars. So, the next time your gaze turns upward, know that you're not just seeing distant lights, but rather the unfolding sagas of billions of years of cosmic history. Isn't it extraordinary to realize that we are all participants in this immense and brilliant tapestry of stellar existence? Nuclear fusion is a truly remarkable process that takes place in the core of stars, where unimaginable environments facilitate the transmutation of elements. To grasp what nuclear fusion truly entails and why it holds such fundamental importance for the universe, we need to explore the captivating realm of stellar power. Within a star's core, temperatures soar to millions of degrees, which, when coupled with immense pressure, fosters a setting where hydrogen atoms can merge. You can picture it as a celestial dance, where hydrogen atoms collide with such force that they combine to create helium, releasing a staggering quantity of energy as light and heat in the process. Without this stellar engine, stars would not illuminate the void, and the universe would be an entirely different reality. What would our universe look like if nuclear fusion were impossible? Without the ability to generate energy, stars would simply extinguish their light, becoming inert, cold spheres. The very existence of life on Earth is contingent upon the warmth and light that our star provides, making fusion the fundamental engine driving existence. The energy produced in a star's core undertakes a long journey to the surface, migrating through dense layers of gas and plasma over a period that can span thousands of years. When this energy finally breaks free, it radiates into the cosmos, lighting up the night and allowing starlight to finally reach your eyes. Just consider that every glimmer of light you observe on a clear evening is an echo from the ancient cosmos, a pulse of energy that has journeyed across vast expanses of time and space. As a star depletes its primary fuel source, its fusion mechanisms evolve into more intricate stages. After consuming its hydrogen, a star will begin to fuse helium, producing heavier elements like carbon and oxygen in a process that resembles a grand celestial alchemy. But the narrative grows even more compelling when a star's fuel is completely exhausted. The most massive stars conclude their lives in a cataclysmic event known as a supernova, an explosion that unleashes incredible energy and forges even heavier elements, such as iron. This is not merely a stunning visual spectacle. It is a pivotal event that helps to sculpt the universe by dispersing these vital materials throughout the cosmos, providing the building blocks for new stars, planets, and perhaps even life itself. And what is the destiny of smaller stars? They may experience a more graceful exit from the cosmic stage. Their end is quieter as they transform into white dwarfs, yet these stellar remnants are also integral to the universe's life cycle. While they cool and gradually dim, they release the elements they manufactured during their active lives, thereby contributing to the material that will form future stellar generations. Nuclear fusion is more than just the powerhouse of stars. It's a phenomenon that illuminates our own position in the cosmos. Every one of us is fashioned from the very same stardust created in the hearts of these brilliant giants. So, when you look up at the night sky, remember that you're not just observing light, you're seeing the consequence of eons of nuclear fusion, a powerful reminder that we are all bound together in a single cosmic narrative. The effort to comprehend nuclear fusion has spurred scientists to try and recreate this stellar process here on our planet, aiming to develop a source of sustainable and nearly inexhaustible power. Should they be successful, we could find ourselves on the threshold of a revolutionary age in energy, drawing inspiration directly from the mechanism that fuels the stars. However, in many respects, nuclear fusion continues to be an enigma. Despite our progress, much remains to be discovered about how to completely control its immense potential. Each new insight moves us one step closer to deciphering the fundamental principles of how nature manages this incredible force. Nuclear fusion is undeniably one of the most magnificent cosmic phenomena. It demonstrates how simple elements can be converted into the energy, light, and warmth that nurture the worlds we recognize. Contained within every radiant star is a story of metamorphosis, a narrative of energy transforming into existence, and in the end, into us. So, on your next clear night, take a moment to reflect on the breathtaking ballet of nuclear fusion occurring in their cores. Every twinkle of light serves as a testament to nature's power and shows how the universe we call home is shaped through intricate and beautiful processes. And yet, nuclear fusion is just one of many marvels that await us as we continue to explore space. What other secrets does the cosmos keep? Our journey of discovery has just begun. Stellar systems can be thought of as immense celestial collections, where every star is an individual piece that shines with its own distinct character. But how do these collections come into being, and what accounts for their fascinating variety? To answer this, you must first appreciate the sheer scale of space and the reality that stars are rarely solitary entities. Each one is born inside a nebula, which is an immense concentration of gas and dust adrift in the cosmos. Think of it as an enormous celestial laboratory where the basic ingredients of hydrogen, helium, and other light elements are combined to create something truly magnificent. Under the right circumstances, these immense clouds of gas and dust succumb to their own gravitational pull, collapsing inward to create a hot, luminous sphere. It's truly incredible to consider how the universe, much like a master chef blending ingredients, brings together fundamental elements to give birth to a star. But what journey does a star undertake after its formation? Stars, not unlike people, progress through a distinct life cycle, beginning their existence as blazing giants that shine brilliantly by fusing hydrogen into helium deep within their cores. This fusion process acts as a celestial furnace that can burn for millions or even billions of years, providing a nearly inexhaustible supply of energy. Can you even fathom a lifespan that long? Certain stars are capable of illuminating the cosmic darkness for ages, serving as almost eternal beacons. Inevitably, however, every star begins to deplete its primary fuel, causing its brilliant bonfire to fade as it transitions into the next stage of its existence. Depending on its initial mass, a star will follow one of several evolutionary paths. Smaller stars, such as our own Sun, are destined to expand into red giants before ultimately casting off their outer layers. What remains is a dense, hot core that cools over eons, becoming what we call a white dwarf. But what is the fate of the truly massive stars? They conclude their lives in a supernova, a cataclysmic explosion so luminous that for a fleeting moment it can outshine an entire galaxy. Isn't it fascinating that a star can meet its end with such spectacular grandeur? Yet, even after a star dies, its influence persists, as the leftover nebulae provide the perfect cosmic nurseries for the formation of new stars. This process establishes a magnificent cycle in the universe, where death invariably paves the way for new life. It naturally leads us to question how these stars affect the space around them, as they release elements like carbon, oxygen, and nitrogen, which are essential for life as we know it. Contemplating this cosmic recycling raises another compelling question. How are stars arranged within their larger systems? Just like our solar system, where planets orbit the Sun, the cosmos is filled with stellar systems that can contain multiple stars. These arrangements range from simple binary pairs, where two stars orbit a common center of gravity, to sprawling star clusters that bring together thousands of stars in a dense, brilliant community. Gravity serves as the fundamental force organizing these celestial structures, acting like a cosmic conductor guiding each star and planet to maintain its proper place. But what occurs when a great number of stars are concentrated in one region? These stars can engage in complex gravitational interactions, a cosmic dance of attraction and repulsion that might result in stellar mergers or the formation of even more intricate systems. When we discuss these systems, we must also consider the planets that accompany these stars, which display an astonishing diversity. Some worlds may be rocky, much like Earth, while others are colossal gas giants. You can find planets with thick, crushing atmospheres, planets adorned with luminous rings, or even worlds with oceans of molten lava, each one telling a unique story of its origin and journey through time. By exploring these vast and varied stellar systems, we gain a deeper understanding of our own place within the universe. Every new discovery about a distant star or planet brings us another step closer to solving the grand mysteries of the cosmos. As you observe the ballet of stars and their systems, it's important to recognize that each point of light tells its own tale, a life cycle deeply connected with countless others, weaving the very fabric of our universe. As you gaze up at the night sky, remember that those twinkling lights are far more than just distant objects. They represent stories of life, death, and renewal, beckoning us to continue our exploration into the infinite mystery of space. Within this immense cosmic theater, planets engage in a celestial ballet that has captivated humanity for millennia. But have you ever stopped to think about the mechanics of their movement? This dance of the planets is an extraordinary choreography governed by the unwavering laws of physics and gravity. What unseen forces hold these worlds captive in their orbits? The solution is found in the subtle but relentless pull of gravity. Every planet follows its own unique trajectory, with some moving more swiftly than others, creating a kind of cosmic symphony where each body has its own tempo and role. Imagine our Earth perpetually spinning on its axis as it embarks on an endless journey around the Sun, performing a flawless dance that balances its forward momentum against the Sun's gravitational embrace. Gravity, the force we so often overlook, is the invisible thread that orchestrates this entire performance. Without it, planets would simply drift aimlessly through space. But how does it achieve this? Picture the Sun as a massive bowling ball placed in the center of a stretched fabric, and the planets as smaller marbles rolling around it. The closer a marble is to the central mass, the faster it must move to avoid being pulled in, resulting in a continuous interplay of forces where each planet finds its perfect equilibrium. Even our closest companion, the Moon, participates in this cosmic dance, its orbit not only circling the Earth, but also exerting its own influence on our world. The Moon's gravity is responsible for our ocean tides, creating a rhythmic ebb and flow. Just think what it would be like if your own movements were dictated by another celestial body. In turn, the Moon is held in its path by Earth's gravity, forming a unique and inseparable bond between the two as we journey together through the cosmos. Picture an enormous troupe of dancers, where every performer has a unique style, but moves to the same music. The gravitational interplay between them can shift their orbits over time, making it seem as if they are adjusting to the musical rhythm. In certain systems, the planets are incredibly different from one another, with some being gas giants and others being small, rocky worlds. This contrast introduces another layer to the performance, where each planet type claims its own specific movement and area. You might wonder how a seemingly light, gaseous planet could influence a solid, rocky one, and the solution is found in gravity's strength, which acts like a conductor leading an orchestra, making sure every member stays on beat. Distance is another crucial element in this celestial performance. Planets that are farther from their sun travel more slowly, as if they are engaged in a calm waltz, whereas those in closer proximity circle rapidly, like they are part of a vibrant celebration. Can you fathom residing on a planet where a single year, one orbit around its star, takes several decades to complete? For some bodies in our universe, this is their everyday reality. And the performance isn't just about gravity. The spin of the planets also shapes their dance, with some rotating on their axes in mere hours, while others require many days, a factor that can determine their climate, atmosphere, and potential to sustain life. Have you ever considered what a day might feel like on a slowly rotating planet, where the sun appears to crawl across the firmament? It's also important to acknowledge the role of asteroids and comets, as these smaller bodies can intersect planetary orbits and momentarily disrupt the dance. Much like an unexpected guest interrupting a performance, they can introduce unforeseen shifts. While they are frequently perceived as a threat, their presence also serves as a reminder that the cosmos is brimming with surprises. The arrangement of planets is equally compelling. In some systems, they maintain an almost perfect alignment, but in others, their orbits are far more chaotic. The history of a planetary system, including its past collisions and mergers, dictates how its components are structured today. Through our observations of other solar systems, we've learned that this planetary dance is not exclusive to our own cosmic neighborhood. Thousands of exoplanets are orbiting distant stars, each with a distinct tempo and flair, making you wonder what stories they might share if they had a voice. The quest to find these worlds and map their orbital patterns stands as one of modern astronomy's most significant challenges. Ultimately, the dance of the planets is a tribute to the fundamental nature of our universe, teaching us about the elegance of gravity, the sheer variety of celestial objects, and the harmony that can be found within chaos. Each orbit and every movement confirms that even though you might feel isolated in this immense cosmos, you are, in fact, witnessing a cosmic ballet that has been in motion for billions of years. So, when you next gaze upon the starry night, remember that you're not just looking at points of light. You are observing performers in a perpetual choreography, each fulfilling its part in the grand cosmic spectacle. Within the immense universe we occupy, there are endless mysteries that captivate our minds. And among the most compelling is the existence of exoplanets, worlds that circle stars far beyond our solar system. The question is, how can we be certain they are there? The credit goes to human ingenuity and the advanced technologies we've engineered to peer at the most remote stars. For decades, astronomers have been studying the heavens with telescopes built to catch minute fluctuations in a star's brightness. When a planet orbiting another star crosses in front of it from our perspective, an event known as a transit, it momentarily dims the starlight. This slight dimming can be the first indication of a distant world, one that might even possess conditions favorable for life. It was through observations like this that we began to grasp that we are not alone in the cosmos. This search has unveiled an incredible variety of worlds, from gas giants larger than Jupiter that orbit so near their stars their surfaces are hotter than an oven, to small, rocky planets that might share characteristics with Earth. Each new discovery prompts you to ask what might exist on these planets. Could they hold water, the very basis of life? Or do they possess atmospheres entirely alien to our own? Some of these exoplanets are situated within the habitable zone, which is the area around a star where the temperature is suitable for liquid water to exist on a planet's surface. Just imagine a world covered by vast oceans with continents capable of supporting life. The mere thought of potential creatures, plants, and entire ecosystems on these faraway worlds ignites the imagination of scientists and dreamers. The techniques we employ to find these exoplanets are as varied as the worlds themselves. In addition to the transit method, astronomers use the radial velocity technique, which tracks the subtle movement of a star as it's pulled by the gravity of an orbiting planet. This gravitational tug-of-war between the planet and its star creates a kind of cosmic waltz, where each partner affects the other's motion. It's truly amazing when you consider that we can confirm a world's existence thousands of light years away just by observing the gravitational influence it has on its star. Our search has led us to solar systems that defy our current understanding of the universe. Some systems contain multiple exoplanets in complex orbital patterns, while others display strange arrangements, like planets with highly elongated, elliptical orbits. This incredible diversity forces us to reconsider our theories on how planetary systems are formed and the evolutionary journeys they have undergone over cosmic history. This fascination goes far beyond mere discovery, as studying these remote worlds also deepens our knowledge of our own planet, Earth. By analyzing the atmospheric makeup of an exoplanet and comparing it to our own, we can gain new insights into how life originated and developed right here. It makes you wonder if an Earth-like exoplanet could one day provide a new stage for human exploration. The quest to understand these distant planets is, in many ways, a quest to better understand ourselves and our place in the universe. This prospect naturally inspires a great deal of optimism and enthusiasm. Yet the quest to find life on other worlds presents a formidable challenge, primarily because the sheer scale of the cosmos and the immense distances between celestial bodies are truly staggering to comprehend. With instruments of ever-growing power, like the James Webb Space Telescope, we are finally gaining the ability to peer into the atmospheres of distant exoplanets. Through the careful analysis of starlight filtering through these alien skies, we can identify chemical signatures, such as oxygen or methane, that could signal the potential for life. At its heart, this entire endeavor is a profound attempt to resolve one of the most ancient questions our species has ever asked. Are we the only thinking beings in the cosmos? While science fiction has certainly ignited our collective imagination with tales of spacefaring adventures, the reality of exoplanetary science is proving to be far more incredible than any story you might have read. Every new finding unfolds like a new chapter in a boundless cosmic narrative, rich with unforeseen developments and stunning revelations. With each step forward in our exploratory journey, every newly identified exoplanet provides a fresh tale and another chance to grasp the incredible variety of the universe, all of which stands as a powerful tribute to human cleverness. It is through global cooperation and relentless technological advancement that we have managed to look past the confines of our own solar system. When an astronomer gazes into a telescope, they transform into a pioneer of uncharted territory, searching for solutions to the universe's countless mysteries. This quest for exoplanets doesn't just hold out the hope of discovering alien life, it also compels you to contemplate your own being and humanity's position in the grand scheme of things. The notion that we could belong to an interplanetary fellowship within this immense cosmos is a genuinely thrilling concept. What mysteries are locked away on these remote worlds, and what sagas are still waiting to be written? As you look up at the night sky, consider that each point of light might be a sun with planets of its own, a testament to the fact that human curiosity has no limits. This journey of discovery is far from over. Space is an endless sea of potential, ready for us to explore. Among the most enigmatic and compelling occurrences in the cosmos are black holes, but their origin story is fascinating. To grasp how they come to be, you must first picture a star of enormous mass, a brilliant orb blazing in the void, producing energy through nuclear fusion deep within its core. An incredible metamorphosis is set in motion at the precise instant this stellar giant finally runs out of fuel. As a colossal star reaches the conclusion of its existence, it undergoes a cataclysmic detonation called a supernova. This is more than a simple flash of light. It represents a crucial juncture that can culminate in the birth of a black hole. In the midst of this explosion, the star's external layers are violently cast out into the cosmos, abandoning an incredibly compressed remnant at its center. The reason this core can transform into a black hole lies in the force of gravity. In the aftermath of the star's collapse, the core's gravitational field is so powerful, it begins to draw in all nearby material. If the core possesses enough mass, its pull intensifies to a point where absolutely nothing, including light itself, can break free. This is the genesis of a black hole. a region of space-time so warped by gravity that it ensnares anything that ventures too close. It's truly mind-bending to consider that regions exist in the cosmos where light itself is trapped. Yet, science has yet to provide a conclusive answer about what is concealed within a black hole. The prevailing theory suggests the presence of a singularity, a point where our current understanding of physics completely breaks down. Picture a location where space and time operate under rules entirely alien to your everyday reality. This is the singularity, and encircling it is the event horizon, the ultimate threshold from which no escape is possible. What would you actually experience if you were to pass the event horizon? As you neared this boundary, the force of gravity would escalate dramatically, leading to a bizarre effect known as spaghettification. Imagine your body being simultaneously stretched and squeezed, contorting and elongating as you get closer. In this way, black holes are not just cosmic puzzles. They are phenomena that fundamentally defy our perception of the physical world. Furthermore, black holes have a significant impact on the development of galaxies. It is widely thought that most galaxies harbor these cosmic behemoths at their cores, where they shape the birth and expansion of everything around them. Can you picture residing in a galaxy whose central point is a black hole? Its immense gravitational influence alters the paths of stars and planets, fostering a truly dynamic and fascinating cosmic neighborhood. These objects are far from stationary. They actively expand by devouring nearby matter, from entire stars to clouds of gas and dust. This consumption generates a brilliant emission called accretion radiation, visible across vast cosmic distances. Some of the most voracious black holes even launch powerful jets of particles that travel at nearly the speed of light. This spectacular display offers vital clues into the fundamental properties of these mysterious entities. The very presence of black holes has spurred captivating new ideas regarding the fabric of space-time itself. Certain theories propose that these objects might serve as portals to alternate universes or other dimensions entirely. Just think about the possibility of traversing a black hole to emerge in a totally different reality. While this concept is a staple of science fiction, ongoing scientific inquiry continues to explore whether it could have a basis in fact, with every new finding moving us closer to solving the deepest riddles of the cosmos. Research into black holes has also fueled progress in the realm of theoretical physics. You see, one of the most significant challenges in modern science is finding a unified theory that can merge general relativity with quantum mechanics. Black holes exist precisely at the meeting point of these two fields, forcing us to ask profound questions about the very fabric of time, space, and reality itself, and prompting us to wonder if we can ever truly grasp their mechanics. Because of breakthroughs in technology, we've recently gained the ability to see black holes with our own eyes. The first ever image of a black hole, produced by the Event Horizon Telescope collaboration, was a true turning point for modern astronomy. This picture, which captured the silhouette of the black hole at the heart of the M87 galaxy, represented an immense leap forward in our knowledge of these cosmic behemoths, leaving us to anticipate what other secrets they might one day unveil. The investigation of black holes does more than just expand our comprehension of the universe. It also encourages us to contemplate our own place in it. Faced with such an immense and enigmatic cosmos, you might naturally question where you fit in. The presence of these celestial giants serves as a powerful reminder that there is so much left for us to find and to comprehend, sparking curiosity about the other mysteries the universe still conceals. Ultimately, black holes stand as a testament to the sheer scale and intricacy of the cosmos. They compel you to peer beyond the familiar and to challenge what you hold to be certain. As our exploration of the universe presses on, black holes will undoubtedly remain a source of deep fascination, a symbol of science's farthest frontiers and a persistent call to keep searching for answers. Each discovery about them could unlock a more profound grasp of reality and our role within this grand cosmic journey. Within the vastness of the cosmic ocean, where every star acts as a guiding light in the darkness, you'll discover the awe-inspiring phenomenon of galaxies. These are immense collections of stars, gas, dust, and dark matter, functioning like distinct islands scattered across space, each possessing its own unique form and arrangement. Some take on a spiral shape, resembling radiant whirlpools, while others are elliptical, with a softer and more uniform appearance. And some are even irregular, appearing sculpted by cosmic chance. I find it helpful to imagine galaxies as sprawling cities. At the core of many, including our own Milky Way, resides a supermassive black hole, an immense gravitational force that anchors everything around it. Think of it as a central plaza where all activity converges. Stars orbit this center like the inhabitants of a metropolis, following gravitational paths that impose order and maintain the entire structure's delicate balance. When you gaze at the night sky, it's natural to feel humbled by the universe's sheer immensity, which often leads to an intriguing question: just how many galaxies exist? Current estimates from astronomers suggest there could be over 2 trillion galaxies within the observable universe. That's a staggering number of stellar systems and potential worlds awaiting exploration, with each one serving as a unique cosmic laboratory where the fundamental processes governing matter and energy unfold. Every galaxy possesses its own epic history, a story that plays out over billions of years. Their formation begins with minor ripples in the gravitational field that gather clouds of gas and dust. These clouds gradually condense to ignite the birth of stars, transforming each galaxy into a complex ecosystem. Here, stars are born, they live out their lives, and their remains provide the raw materials for new stellar generations in a perpetual cycle of cosmic creation and destruction. Galaxies are also the settings for some truly breathtaking events. Have you ever considered what happens when galaxies collide? These interactions are like a dramatic celestial ballet that reshapes everything involved. The gravitational pull between 2 colliding galaxies can warp their structures, fling stars from their orbits, and sometimes result in their complete merger into a single, larger galaxy. While this cosmic process can take billions of years, it triggers intense bursts of star formation. This brings us to the incredible diversity among galaxies, which can be sorted into distinct categories. Spiral galaxies, as I've mentioned, are defined by arms coiling out from a central hub. Elliptical galaxies, in contrast, are more smoothly spherical and lack such pronounced features. This classification system helps us piece together how different galaxies form and change over cosmic time. But the real puzzles are the irregular galaxies, whose chaotic forms often point to a history of violent gravitational encounters. The light reaching us from these galaxies carries tales from their distant past. When you observe a galaxy far away, you are essentially looking back in time, sometimes by billions of years. By analyzing this ancient light, astronomers can deduce the chemical makeup of its stars, map out its gas and dust, and gauge the activity around its central black hole. Every shimmer and hue is a piece of evidence revealing the evolutionary story of that galaxy. However, much of a galaxy remains invisible to us. Dark matter, an enigmatic substance that doesn't emit or interact with light, is a critical component of galactic structure. While we can't observe it directly, Its gravitational effects are unmistakable, providing the necessary cohesion and stability that hold a galaxy together. You can think of it as the unseen scaffolding that supports the entire cosmic edifice, ensuring everything stays in place. The question of our solitude in the universe is intrinsically tied to the existence of galaxies. With billions of stars in every galaxy, many hosting their own planetary systems, the prospect of other life-supporting worlds becomes almost overwhelming. This thought invites you to consider our own position in the cosmos and fuels the ongoing quest for life beyond our home planet, making us wonder just how many other civilizations might be looking up at their own night skies. With every improvement in our telescopes, our grasp of galaxies grows more profound. Advanced technologies now permit you to peer into corners of the universe that were once completely hidden from view. However, each new finding only introduces more questions, forcing us to rethink our ideas about the fundamental nature of the cosmos and wonder what other secrets lie waiting in this immense and enigmatic void. Your mental image of a galaxy is likely a massive glowing spiral or a smooth ellipse against the blackness of space. What you might not appreciate is that these colossal structures are not isolated. The universe contains billions of them, each a unique system of stars, planets, and untold secrets. These galaxies can engage with one another, merge, and even crash together in a stunning display of cosmic reinvention. So, what exactly occurs when two gigantic star systems converge in the boundless expanse of space? A galactic collision is one of the universe's most magnificent events, a genuine cosmic ballet that reshapes the architecture and future of these massive stellar assemblies. The real questions are how this dance proceeds and what lasting effects it has on the universe itself. On occasion, galaxies drift near enough for gravity to take hold, initiating a powerful interaction between them. Much like two magnets drawing closer, they exert a pull on each other that is impossible to resist. It is at this point that the truly remarkable performance gets underway. It's crucial for you to realize that these encounters bear no resemblance to a terrestrial car accident. While galaxies seem packed with stars, they are composed mostly of empty space. Consequently, the chances of individual stars actually striking one another during a merger are incredibly small. The primary outcome is a gravitational distortion of the galaxies themselves. Their structures become warped as individual stars are gravitationally flung onto entirely new orbits. You can picture it as an intricate dance where the galaxies swirl and entwine, their spiral arms weaving together to generate novel shapes on a celestial stage. This cosmic waltz is a process that unfolds over millions of years, permanently altering the galactic landscape. But what is the fate of the stars within these colliding galaxies? Gravity can trigger intense clustering, concentrating gas and dust to spark massive waves of star formation. This creation of new stars can increase dramatically, setting off cosmic fireworks across the galaxies. These brilliant bursts of stellar nurseries light up the cosmos, producing breathtaking sights that leave astronomers in awe. Yet, not every aspect of this celestial dance is graceful. Merging galaxies also descend into chaos. Certain stars can be violently cast out from their home galaxies, hurled like projectiles into the interstellar void. Such events can disrupt entire star systems and change the developmental path of the galaxies themselves, making each collision a pivotal moment that shapes the destiny of billions of stars. These galactic encounters are not uncommon cosmic occurrences. In fact, our own Milky Way is currently on a direct path to collide with the Andromeda Galaxy. In approximately 4 billion years, these two great spirals will combine, profoundly altering the view of the night sky for any future inhabitants of Earth. It's captivating to contemplate how their structures will morph, forging new star patterns and perhaps even new possibilities for life to emerge. Galactic interactions can also set off other extraordinary phenomena, like the assembly of galaxy clusters, vast congregations of hundreds or even thousands of gravitationally bound galaxies. Furthermore, these mergers affect the supermassive black holes at the galactic cores. As the galaxies combine, their central black holes can also coalesce, giving rise to an even more colossal entity. In some cases, these collisions may even serve as crucibles for life itself. The resulting blend of elements and energy can create environments ripe for the birth of planets and, ultimately, the emergence of living organisms. While science has advanced our comprehension of these events, you must understand that there is still a vast amount to uncover. Every collision offers a new chance to study how cosmic structures are built and how matter and energy interact in this grand celestial performance. The spectacle of galactic collisions serves as a powerful reminder that, in spite of the cosmos's sheer scale, everything is fundamentally linked. The very forces that sculpt galaxies also have a hand in shaping our own existence. So when you next gaze up at the stars, remember that each point of light is part of a grand, unfolding narrative written across the canvas of space and time. You can see that galaxies are not just static islands of stars. They are vibrant, evolving communities that tell the story of the universe itself. When you gaze up at the night sky, remember that you are not merely seeing stars, but witnessing the outcome of a cosmic dance that has been unfolding since the very beginning of time. At the core of this spectacle is dark matter, one of the most profound mysteries in the universe. We are certain of its existence, even though we cannot see or touch it, which raises a compelling question. How can something so imperceptible have such a monumental effect on everything around us? To begin to understand this, we need to consider how forces operate in the cosmos. Picture yourself in a vast ocean where all you can see is water, but you know that powerful, unseen currents are guiding everything beneath the surface. Dark matter operates in a remarkably similar fashion. Its presence is fundamental, though invisible, and scientists have calculated that it accounts for approximately 25% of the universe's total composition. But what exactly is this substance? Unlike the ordinary matter that is composed of atoms and gives rise to stars, planets, and even us, dark matter emits no light or any form of radiation. It behaves like an omnipresent yet invisible shadow stretching across space. So how can we be sure it is there? One of the most compelling pieces of evidence arises from observing the motion of galaxies. When we study a galaxy, we find that stars at its outer edges are moving at astonishing speeds. If we were to calculate the gravitational pull based only on the matter we can see, these stars should be flung out into the void, as their speed is too great to be contained. And yet, that doesn't occur. This behavior strongly suggests that an additional unseen mass is exerting a powerful gravitational force, holding these stars in their orbits. This is precisely where dark matter enters the picture. Imagine you're at a party and feel an unseen person gently nudge you from behind. The push is real, even if you can't see who is responsible. Dark matter functions as this invisible hand, binding stars and galaxies together across the immense expanse of space. And without it, our entire model of the universe would fall apart. Beyond just stabilizing galaxies, dark matter is also the primary architect of the universe's large-scale structure. You can think of it as the threads in a cosmic fishing net, with these invisible filaments connecting all the different parts of the cosmos. Without this underlying framework, the magnificent structures we observe today, like galaxy clusters and superclusters, would simply not exist. The perplexing nature of dark matter has driven scientists to formulate a variety of theories and models to explain it. One of the leading ideas suggests that dark matter is made of exotic particles that we have never before detected. You can think of this scientific quest as assembling a giant puzzle where each new finding about dark matter represents another piece falling into place, gradually revealing the complete image of our universe. Despite our most dedicated efforts, dark matter continues to elude direct detection. We have constructed massive detectors deep underground and have positioned sophisticated observatories in space, all with the goal of capturing this one mysterious particle. To date, however, it has evaded all our attempts. The experience is like trying to catch smoke with your hands. You know it's there, but you simply cannot grasp it. So, why is it so vital that we understand dark matter? The answer is quite simple. Without it, the entire history of the universe ceases to make sense. Its gravitational influence shaped the very formation and evolution of galaxies. Every star, every planet, and every living thing on Earth exists as a result of the fundamental interaction between dark matter and visible matter. It serves as a potent reminder that there is far more to the cosmos than we are able to perceive. As scientists continue their research, each potential discovery about dark matter seems to lead to even more profound questions. Could other forms of matter exist that we have yet to uncover? What part might they play in the universe's development? This search is not only intellectually exciting, but also connects us directly to the fundamental human impulse to understand our place in the cosmos. Dark matter invites us to contemplate the very nature of reality itself. What can we consider real if things exist that are completely beyond our ability to perceive them? It forces us to think beyond the visible, to embrace the idea that the universe is a place filled with mysteries, just waiting to be solved. Each unanswered question unlocks new possibilities, and that is precisely what makes science so thrilling. In the end, although dark matter is an enigma, its influence is undeniable. It serves as the invisible thread that weaves together the fabric of the cosmos, providing it with both form and structure. As we push further in our exploration of space, dark matter will continue to be a symbol of humanity's unending quest for knowledge. With each new discovery, we inch closer to unraveling the secrets of existence itself. But this incredible journey has only just begun. Did you know that the universe possesses a remarkably organized framework that resembles a vast cosmic web? This intricate network spans trillions of light years, connecting galaxies, galaxy clusters, and the very filaments of dark matter. To understand this, imagine a massive three-dimensional map where galaxies are not scattered randomly, but are arranged in clear patterns that unveil the entire history of the cosmos. This grand design is not merely an object of curiosity. It holds the key to comprehending how the universe was formed and how it has changed over billions of years. Scientists have observed that the placement of galaxies is highly uneven. Certain areas are incredibly dense and populated, while others are vast, empty regions that appear completely desolate. The question is, what process caused this to happen? In its infancy, shortly after the Big Bang, the universe was a hot, uniform soup of subatomic particles. As this primordial soup expanded and cooled, tiny fluctuations in its density began to shape the formation of cosmic structures. Areas with slightly more mass began to gravitationally attract more material, which in turn created regions of even higher density. This is how the very first filaments of the cosmic web began to take shape, not unlike what you might see at a crowded party, where a small group of people naturally draws in others to join them. Galaxies tend to gather in groups and superclusters that trace the paths of cosmic filaments, leaving the emptier expanses to become enormous voids in space. But what if I were to tell you that these voids hold their own significance? They are, in fact, crucial for deciphering the history and evolutionary path of our universe. Now, consider how dark matter fits into this grand design. Even though it is invisible to us, we can detect its presence as the unseen force that binds galaxies together, preventing them from flying apart and making their very formation and continued existence possible. The nature of dark matter itself remains a profound puzzle that has captivated scientists for decades. It is estimated to constitute about 85% of all matter in the cosmos, yet its fundamental composition is still unknown to us. Through meticulous observation, we have successfully mapped the distribution of this mysterious substance. When you look into the night sky, you can see stars and galaxies, but what remains hidden is the immense web of dark matter that envelops them, serving as a cosmic scaffold that dictates the shape of the universe and steers the formation of all its structures. Have you ever considered the deep connection between this cosmic web and the life cycle of galaxies? As galaxies travel along these vast filaments, they are drawn into collisions and mergers that create even larger galactic structures. This process of merging does more than just reshape the galaxies involved. It also sparks bursts of new star formation, fueling an unending cycle of stellar birth and death across the universe. The cosmic web serves as much more than just a map of matter's density. It is a direct reflection of the universe's long history. It provides us with a clear understanding of how matter has been arranged over eons and the profound effect this has had on the development of large-scale cosmic structures. With every new observation, astronomers move closer to solving the cosmos's greatest riddles. Imagine for a moment that you could journey through this web, where every galaxy, cluster, and void represents a destination on a spectacular voyage filled with wonder. From the violent explosions of colliding stars to the quiet birth of new worlds, the cosmic web stands as a testament to the universe's staggering complexity and beauty. As our explorations take us further into its depths, this structure forces us to confront fundamental questions about our own existence. If we are just a tiny component of this immense network, what does that imply for humanity? The pursuit of these answers compels us to contemplate our own place within this cosmic narrative. As we continue to explore this intricate labyrinth, each discovery serves as a reminder that the universe is a profoundly dynamic and constantly evolving place. The cosmic web is not merely an assortment of galaxies and dark matter. It is a powerful symbol of the deep interconnectedness that permeates the entire cosmos. Every planet, every star, and every living thing is woven into this magnificent tapestry. And while you might sometimes feel isolated in the sheer vastness of it all, the truth is that you are part of something immeasurably larger. So, the next time your gaze turns toward the night sky, remember that you are seeing more than just distant stars. You are witnessing the cosmic web in motion, a colossal system that has taken billions of years to form and continues to evolve right before you. The universe is a truly incredible place, brimming with mysteries and marvels that still await our discovery. This leads us to another fascinating subject: star clusters, which give us a unique portal into the universe's past. Picture a sprawling celestial garden where the stars are like flowers, each distinct in its own color and light, yet all rooted in the same cosmic soil. This is an apt description for star clusters, which are collections of stars gravitationally bound together, journeying through the cosmos as a single entity. These clusters are primarily classified into two types, globular and open. Globular clusters are like ancient, densely populated cities, packed with old stars that have traveled together for billions of years, whereas open clusters are more akin to vibrant gatherings of energetic, newly formed stars. Picture a sprawling celestial garden where the stars are like flowers, each distinct in its own color and light, yet all rooted in the same cosmic soil. This is an apt description for star clusters, which are collections of stars gravitationally bound together, journeying through the cosmos as a single entity. These clusters are primarily classified into two types, globular and open. Globular clusters are like ancient, densely populated cities, packed with old stars that have traveled together for billions of years, whereas open clusters are more akin to vibrant gatherings of energetic, newly formed stars. Regarding the number of stars, a globular cluster can host hundreds of thousands, while an open cluster might contain just a few hundred or even a few dozen, with each cluster telling its own distinct story. These stellar nurseries begin their existence deep within nebulas, where clouds of gas and dust collapse under their own gravity. As this material compresses and its temperature rises, new stars ignite, forming a cluster that offers a perfect snapshot of cosmic evolution, a history written in light across time. Over time, these newborn stars gather into gravitationally bound clusters that embark on their own celestial voyage. You can think of it as a group of friends who meet at a grand cosmic event and then decide to see the universe together. For astronomers, star clusters are exceptionally valuable. Studying them is like opening a book on the history of the cosmos. By observing the stars within these groups, scientists can piece together the story of how stars form, live, and evolve, essentially witnessing the entire stellar life cycle in a single location. Within globular clusters, you find incredibly ancient stars, some of which are over 13 billion years old. This makes them direct witnesses to a time when the universe was fundamentally different from how it is today. Examining these stellar relics allows scientists to gain a much clearer picture of the cosmos in its infancy. It is truly remarkable to consider that some of these stars have shone since nearly the beginning of time itself. In contrast, open clusters provide an entirely different view. These looser groupings are typically teeming with bright, young stars that are still in their formative stages, making them scenes of intense stellar activity. Here, new stars are continuously being born, as others are just beginning their decline. This perpetual cycle of creation and destruction serves as a powerful reminder that the universe is in a constant state of flux. The interactions among stars within a cluster are also a source of great fascination, as their shared journey through space means they continually influence one another. It's remarkable to consider that certain stars can drift so near one another that their gravitational pull results in a merger, forging a single, more massive and luminous star. It really makes you appreciate the profound influence that stars can exert on each other. However, the story doesn't end there. Star clusters provide us with natural laboratories for investigating dark matter. This enigmatic material, invisible to us but detectable through its gravitational effects, is crucial for both the creation and the persistence of these stellar groups. By analyzing the behavior of dark matter within these clusters, we can gain deeper insights into the fundamental architecture of our entire universe. In some clusters, the stellar population is so dense that the interstellar space is a stage for perpetual interaction. The gravitational tug of neighboring stars keeps everything in motion, fashioning a vibrant landscape of constant flux. You can envision it as a celestial ballet, with every star performing its part in a grand cosmic choreography. What's more, star clusters are cosmic forges, where many of the universe's heaviest elements are created. When massive stars reach the end of their lives and erupt as supernovae, they blast immense energy and newly synthesized elements into space. This material later becomes the raw ingredient for new stars and planets, which leads to a fascinating thought. Isn't it incredible that elements within you might have originated in the core of a far-off, long-dead star? So you see, these clusters are far more than just beautiful celestial sights. They are essential keys to unlocking the universe's history and destiny. Analyzing their makeup, movements, and life cycles allows us to tackle fundamental questions about the origins of our cosmos and what the future may hold. It makes you wonder if we're merely witnessing one small piece of a never-ending cycle. The next time you gaze up at the night sky, I want you to remember that any single star might belong to a cluster, a bearer of cosmic secrets. These stellar families beckon us to look deeper, to contemplate the cycle of existence in the universe, and to anticipate the wonders hidden within this immense celestial garden. Every cluster you see is but a single thread in a vast tapestry of interconnected narratives, all waiting for us to uncover them. Let's consider the function of dust on the grand cosmic stage. Cosmic dust is a quiet but absolutely essential character in the universe's unfolding drama, though it's frequently ignored. Picture an immense sea of gas and particles, where every single speck of dust serves as a miniature brick for building stars and entire worlds. While this free-floating dust might appear trivial, its impact is truly monumental. This cosmic dust originates from two main sources: the cataclysmic explosions of supernovae and the elemental fusion happening deep inside stars. Upon its death, a star ejects a huge cloud of matter that spreads throughout space. This material eventually cools and coalesces into minuscule dust particles. Every one of these grains, no matter how small, is a time capsule from the universe's past, containing elements forged in the heart of a once brilliant star. So, what is the precise mechanism by which this dust drives the formation of new stars and planets? The key is its capacity to draw in and merge with surrounding material. Within nebulae, which are massive clouds of gas and dust, these particles act as seeds for the stars of tomorrow. Gravity takes over as more dust and gas gather, causing smaller particles to fuse into larger bodies until the core of the nebula reaches the ideal state for stellar ignition. Not every speck of dust follows the same path, however. A portion of these grains is destined to become the fundamental material for planets. You can think of the universe as an artist, meticulously selecting the right elements from this cosmic dust to sculpt new worlds. In this light, planets are more than just astronomical objects. They are living chronicles of the dust that formed them, embodying tales of change and growth. It might surprise you to learn that cosmic dust is also critical for the emergence of life. The very elements that constitute this dust, including carbon, oxygen, and nitrogen, are the essential building blocks for life as we understand it. As planets coalesce from this material, they inherit these vital ingredients. So, you see, dust doesn't just construct stars and planets. It also prepares the groundwork for environments where life could potentially thrive. In this way, cosmic dust serves as a link between the cosmos's history and its potential future. When this dust evolves into stars and planets, it sets the scene for the story of life itself to begin. Every single atom that makes you who you are, and every water molecule you consume, can be traced back to this primordial stardust. It's a truly mesmerizing concept that we are, quite literally, crafted from the remnants of stars. Furthermore, the influence of cosmic dust extends beyond its role in creating nebulae and planets. It's an active participant in cosmic dynamics, capable of obscuring light from faraway stars. This creates dark patches in the sky that, paradoxically, enable us to observe the universe in incredible new ways. Much like a cloud passing in front of the sun can reveal details you couldn't see before, these dust clouds hide some cosmic wonders while revealing others. For astronomers, investigating this cosmic dust presents a significant challenge. They employ powerful telescopes and sophisticated space probes in an effort to unlock the secrets concealed within these microscopic grains. With every technological leap, we gain the ability to see this material in greater detail, leading to discoveries like the presence of complex molecules, even life's foundational components. This exciting find suggests that cosmic dust may have been instrumental not just in our solar system's birth, but in seeding life elsewhere in the cosmos. You can also find cosmic dust right here at home, within our Milky Way galaxy. Its spiral arms harbor immense dust clouds that, while not visible to us directly, exert a massive influence on new star formation. This unseen cosmic process is absolutely crucial for our galaxy's ongoing evolution. Without it, the stellar life cycle would break down, resulting in a profoundly different universe. Ultimately, examining this dust provides us with an invaluable perspective, offering a direct glimpse into the ancient history of the cosmos itself. By examining the makeup of this cosmic dust across various celestial regions, scientists can deduce how the universe has evolved over billions of years. Think of each speck of dust as a miniature fossil that holds the narrative of its own creation, its voyage through space and time, and its impact on the countless generations of stars and planets that have come and gone. So when you next gaze up at the night sky, I want you to appreciate that every star, planet, and glimmer of light is intricately tied to this cosmic dust, which, despite seeming insignificant, plays a foundational role in the story of our universe. Now, let's journey from the microscopic to the magnificent, as we explore the rings of Saturn, one of the most breathtaking spectacles in our solar system. Have you ever looked toward the heavens and contemplated what exists far beyond our sight? Saturn, the second largest planet, captivates us not just with its sheer scale, but with its extraordinary system of rings. What are these rings made of? How did they come to be? And what makes them so profoundly special? Let's find out together. The rings surrounding Saturn appear as a colossal necklace of celestial gems, shimmering with colors and textures that defy our imagination. These structures, composed primarily of ice and rock fragments, stretch out for more than 200,000 kilometers. What is truly remarkable is that despite this immense span, their vertical thickness is merely a few hundred meters. You can visualize it as a gigantic, paper-thin disk where every single particle of ice is an essential component of the whole. So, what force is responsible for crafting such astonishing beauty? The answer is gravity. With its immense mass, Saturn functions like a cosmic anchor, drawing in these countless icy and rocky particles and holding them in a steady orbit. While the planet's gravity provides the structure, it also animates the rings. A nearby moon's passage can send ripples through the material, creating exquisite waves and patterns. Can you picture that silent dance of glittering particles, all moving in perfect harmony with the laws of physics? Let's delve a little deeper into the composition of these rings. Although they present a dazzlingly white appearance from a distance, they are in fact made from many different kinds of ice, with some fragments reaching the size of mountains. Interspersed with this ice are minuscule particles of dust and rock, which combine to produce a singular visual display. It's as if you're witnessing a vast cosmic canvas upon which nature has painted a masterpiece using its own unique palette. The origin of the rings is a fascinating topic, and the most widely accepted theory proposes they are the remnants of a moon that strayed too close to Saturn. The planet's gravitational pull would have been so overpowering that it ripped the moon apart, shattering it into the myriad pieces that now constitute this spectacular system. Isn't it incredible to think that such a violent, destructive event could result in something of such profound beauty? However, the allure of Saturn's rings extends beyond their visual splendor, as they play a critical part in our comprehension of the solar system's history. By analyzing the rings, scientists can uncover clues about how planets and their moons first formed. Every single particle orbiting Saturn carries a story, a narrative that stretches back billions of years into the past. Just think about the secrets and hidden knowledge they might one day reveal to us. The rings are far from static. They are in a state of perpetual motion and transformation. Some particles may collide, forging new structures and patterns within the rings. Other pieces can be pulled away by the gravity of Saturn or its moons, causing the system's shape and dimensions to alter over time. It's a powerful reminder that in the grand scale of the cosmos, nothing lasts forever, as scientists believe the rings could completely disappear within 100 million years. The interplay between Saturn and its moons has a profound effect on the ring's structure, with some moons acting as cosmic shepherds that help to contain the ring material. The moon Prometheus, for instance, serves a vital function by sculpting the edges of the rings and creating features known as gravitational loops. It's as if these moons are celestial gardeners, diligently tending to their magnificent, orbiting garden of ice and rock. As you observe the rings, you'll also see that they are not all uniform. Saturn actually possesses several distinct rings, each with its own unique properties. The most well-known, the A ring, is the brightest and most densely packed. In contrast, you have other rings, such as the F ring, which are significantly thinner and more difficult to perceive. The reason for these variations lies in the quantity and size of the particles that constitute each individual ring. Sunlight is also an essential ingredient in the ring's stunning appearance. When light from the sun strikes them, the countless ice particles reflect it in a way that generates a spectacular array of colors and shimmering light. The rings can seem almost transparent or intensely brilliant, depending on the sun's position and your viewing angle. It is truly awe-inspiring to consider that the light you see has traveled millions of kilometers for the sole purpose of illuminating these majestic structures. Ultimately, Saturn's rings are so much more than just a breathtaking celestial sight. They stand as a testament to the history of our solar system, reflecting the intricate dance of cosmic forces and the sheer beauty of the natural universe. Each fragment that composes these rings tells its own tale, a story deeply interwoven with the mysteries of existence. Can you imagine what else we might discover about them, and what they might teach us about our own place in the cosmos? So the next time you gaze into the sky and spot Saturn, I hope you'll remember that its rings are more than a beautiful image. They serve as a powerful reminder of the universe's complexity and wonder, a universe that is perpetually waiting for us to explore and comprehend it. Human curiosity has always driven research and discovery, and those who continue to look up will undoubtedly keep unraveling its secrets. Are you ready to continue the exploration? In the realm of modern cosmology, few concepts are as utterly fascinating and astonishing as the expansion of the universe. But what does this idea actually mean in practice? To help you understand, picture yourself slowly inflating a balloon. As the air fills it, the surface stretches and expands, causing every single point to move farther away from all the others. Our universe behaves in a remarkably similar way, constantly growing larger, a fact we have confirmed through several incredible discoveries. The initial piece of evidence for this expansion was uncovered in the 20th century by the astronomer Edwin Hubble. He observed that galaxies are receding from us and that their speed increases with their distance. It is truly mind-boggling to consider that space itself is stretching, pulling the galaxies along with it for the ride. This realization prompted a compelling question. If the universe is currently expanding, what existed before this process began? The pursuit of an answer leads us straight to the renowned Big Bang. This event should not be pictured as an explosion within space, but rather as the very expansion of space itself from a singular point. During its earliest moments, the universe was incredibly hot and dense. Ever since, it has been continuously expanding and cooling. Over vast stretches of time, this process allowed for the formation of particles, then atoms, and eventually gave rise to the stars and galaxies that you and I see today. So you might ask, what significance does this cosmic expansion hold for us? This universal expansion also presents a direct challenge to our conventional understanding of gravity. Under normal circumstances, you can think of gravity as a cosmic adhesive that holds matter together. However, on the grandest cosmological scales, gravity encounters a formidable competitor, a mysterious force known as dark energy. It appears that this enigmatic force is actually accelerating the universe's expansion, causing galaxies to fly apart from one another at an ever-increasing rate. A notion that compels us to re-examine the very fabric of reality. Contemplating the expansion of the universe naturally leads us to ponder the ultimate destiny of everything that exists. Based on what we know, what does the future hold if this expansion continues without end? Some scientific theories propose a future where galaxies drift so far from one another that they become entirely invisible from our vantage point. In a universe that expands infinitely, all stars will eventually exhaust their fuel, and the cosmos will gradually descend into a cold, dark, and desolate state. Despite its cosmic scale, the expansion of the universe is not merely some distant phenomenon. It carries tangible implications for us here and now. For instance, the redshift of light arriving from faraway galaxies is a key tool for understanding how the cosmos operates. As a galaxy moves away from us, the light it emits is stretched, shifting it toward the red end of the visible spectrum. This effect allows us to measure the speed of galactic recession and gain deeper insights into the universe's fundamental nature. Furthermore, the scientific inquiry into universal expansion has spurred the development of instruments and technologies that have a real impact on our daily lives. The advanced telescopes and scientific apparatus we rely on today are built upon principles of physics that were first discovered through studying the cosmos. Have you ever stopped to consider how progress in astronomy might actually influence the technology you use every single day? Engaging with the idea of an expanding universe also encourages us to reflect on our own position within this immense cosmic tapestry. Every one of us is an integral part of this grand narrative that has been unfolding over billions of years. When you gaze up at the stars, you are not just witnessing the distant past. you are also catching a glimpse of the future of a universe in a state of perpetual transformation. Yet, the expansion of the universe is far from the only mystery that envelops us. The questions surrounding the fundamental nature of time and space run deeper than we can currently fathom. What if time doesn't flow in a straight line, but can actually bend and distort in ways we have yet to comprehend? The ongoing expansion of the cosmos forces us to question our deepest assumptions about the reality we perceive. Within this vast cosmic theater, human curiosity emerges as a central character. The drive to acquire knowledge about our universe is one of the most fundamental characteristics of our species, compelling us to look to the heavens and question our place among the stars. It is perhaps this very spark of curiosity that first lit the torch of scientific inquiry and exploration. As our observations and studies of the universe persist, it is crucial to remember that the pursuit of knowledge is a never-ending journey. Every discovery we make only leads to a fresh set of questions, beckoning us to venture further into the unknown. So, the next time you find yourself looking at the night sky, think about the magnificent expansion of the universe and all the wonders that still await discovery. The expansion of the universe is more than just a concept in physics. It serves as a profound invitation to reflect on our own existence and the meaning of life within a cosmos that is forever changing. It reminds us that we are all part of something immeasurably larger than ourselves, and while we may feel insignificant at times, our questions and our curiosity are vital contributions to humanity's collective understanding of the universe. In this quest, each of us has the potential to be an explorer. What new frontiers, then, are waiting for us in the future? What cosmic secrets will be unveiled by the next generation of scientists and visionaries? The solutions to these questions might be closer than we realize, as our journey of discovery is only just getting started. One of the most thrilling tools we now have for this exploration is the study of gravitational waves, a phenomenon that sounds like science fiction, but is very much a reality. To understand them, imagine space-time as a flexible fabric that contains everything in existence. When an object with immense mass, like a star or a black hole, moves through this fabric, it creates ripples, similar to how a stone creates waves when tossed into a pond. These ripples are what we call gravitational waves, and they are essentially the echoes of dramatic cosmic events that have occurred in the most remote corners of the universe. Astronomers have identified that the most potent sources of these waves include the collision of black holes, the violent explosions of supernovae, and the merging of neutron stars. When two black holes circle each other and finally coalesce, they unleash an amount of energy so staggering it's equivalent to that of billions of suns combined. This release of cosmic energy travels across space in the form of waves that you and I can actually detect here on Earth. So how are we certain they exist? Back in 2015, scientists working with the Laser Interferometer Gravitational Wave Observatory, also known as LIGO, declared the very first successful detection of these gravitational waves. It was a landmark event that validated a prediction Albert Einstein had made over 100 years prior in his theory of general relativity, sparking palpable excitement throughout the scientific world because it represented more than just a discovery. It was the dawn of a new era for observing the universe. Detecting gravitational waves is a remarkably delicate undertaking. The instruments at observatories like LIGO possess such extreme sensitivity that they are capable of registering shifts in distance smaller than the width of a single proton. To give you some perspective, that's comparable to trying to measure the thickness of one of your hairs from several kilometers away. This is the level of precision needed to notice these waves as they travel through our planet, causing space itself to stretch and compress in a way that allows detectors to record the subtle alterations. But what exactly do these waves reveal to us? Every signal that is captured tells a unique story about the cosmos. For instance, when scientists study the waves generated by the collision of two black holes, they can deduce the masses of the objects involved and even calculate the distance at which the merger happened. This information not only enhances our comprehension of the dynamics of these celestial bodies, but also provides valuable clues about their formation and evolution throughout cosmic history.
In essence, the study of gravitational waves is revolutionizing the field of astronomy.
For centuries, our observations of the universe have been conducted almost exclusively through the medium of light. Gravitational waves, however, give us the ability to actually listen to the events unfolding in space. You could imagine that the universe possesses its own auditory language, with gravitational waves acting as its deepest and most resonant tones. With each new signal we receive, we are essentially deciphering another part of this grand cosmic symphony.
So why does this breakthrough carry such immense weight?
Gravitational waves provide us with a completely new method for examining cosmic events that might otherwise remain hidden from our view. Explosions of supernovas, for example, can be challenging to observe in particular ranges of the light spectrum. Yet gravitational waves enable us to sense them regardless of their direction. This capability dramatically broadens our understanding of the universe and opens up fresh avenues for discovering phenomena previously unknown to us. The science of gravitational waves also brings up fascinating questions concerning the very nature of our universe. For instance, could there be more massive objects in space than what we can currently perceive? These waves could become a crucial tool in helping us identify dark matter and other mysterious phenomena that we are still far from fully grasping. Every detection is like turning to a new chapter in a cosmic book that is still in the process of being written, and each new find raises even more questions for us to explore.
As our technology continues to evolve, the sensitivity of these detectors is set to improve, which suggests that in the future, we may be able to capture gravitational waves from even more remote and ancient cosmic events. Just imagine having the capacity to hear the lingering echo of the universe's creation, a moment that transpired more than 13.8 billion years ago. The potential here is as boundless as it is thrilling. This quest for gravitational waves has also spurred remarkable international cooperation. Researchers from all corners of the globe now collaborate within a network of observatories to capture and analyze these cosmic ripples. This effort underscores the critical importance of uniting scientific endeavors, bringing together brilliant minds who are all dedicated to the shared objective of unraveling the universe's deepest secrets.
Ultimately, gravitational waves represent something far more than a mere physical phenomenon. They serve as a powerful reminder of just how little we truly know and how much more remains for us to discover. Every time we manage to hear the universe whisper through these waves, you and I move a little closer to answering the profound questions about our own existence and our place on the immense stage of the cosmos.
So, what does the future hold for this field? As we continue to create new technologies and observational techniques, gravitational waves will almost certainly unveil secrets we cannot yet even imagine. It's possible that in the not-so-distant future, you and I will witness the discovery of events that completely transform our understanding of physics, cosmology, and in the end, ourselves. This grand adventure is only just getting started, and every new detection marks another step toward comprehending the full grandeur of the universe.
The search for life on other worlds is a subject that has held humanity's fascination since the dawn of time. Could another planet just like ours exist, one that is brimming with light and life? The notion that we might not be alone in this vast universe is undeniably captivating. As you and I look up at the star-filled sky, we can't help but wonder what truly exists beyond our terrestrial home.
When you start thinking about other planets, it is very easy to let your imagination take flight. Within our own solar system, certain worlds have captured our attention far more than others. Mars, for instance, has been the focus of countless scientific investigations. Its surface, featuring deep canyons and towering mountains, makes you ponder whether life could have once thrived there. Is it possible that we might find evidence of microorganisms that once dwelled in its now arid landscapes? The chance of finding water, even if it is frozen, sustains our hope. However, Mars isn't the only potential candidate for life. You should also consider Europa, which is one of Jupiter's moons. Its thick, icy crust, concealing a vast and deep ocean, might present the right conditions for life to emerge. Scientific inquiry has started to explore the concept that life forms akin to those in the depths of our own oceans could potentially thrive beneath this frozen shell. So, who can say for sure? It's conceivable that creatures are swimming in the eternal darkness of that immense alien sea. As we look beyond our immediate solar neighborhood, the exploration becomes even more exhilarating. Exoplanets, which are worlds that orbit distant stars, represent a rapidly advancing area of research. To this day, we have managed to find thousands of them, and a number of these are situated in what is called the habitable zone, an area where the conditions could be just right for liquid water to exist. But what does being in the habitable zone truly signify? You can think of it like finding the ideal location on a farm for plants to flourish. Not too scorching, not too frigid, with the perfect balance of light and water. The sheer diversity among these exoplanets is truly astounding. Some planets are vast gas giants, while others are solid and rocky, and a few possess truly fascinating features. Picture a world where it rains crystals, or where the oceans are filled with molten lava. Despite this diversity, the core question persists: is there life on any of them? For many scientists, the hunt for signals, potential communications from intelligent civilizations, has evolved into an obsession. Endeavors like SETI, the search for extraterrestrial intelligence, are dedicated to listening for a whisper from the cosmos, hoping to find a transmission that proves we are not alone. The quest for life isn't confined to exploring far-off worlds. We are also learning to examine our own surroundings more closely. Here on Earth, we discover extremophiles, which are organisms capable of surviving in the most severe conditions imaginable. From the abyssal depths of the ocean to highly acidic environments, these resilient microbes demonstrate that life can flourish in the most improbable locations. If life can endure such extremes on our planet, is it not possible it could also exist on others? The prospect of life elsewhere in the universe brings up significant philosophical inquiries. Should we find it, how would that discovery reshape our view of ourselves and our position in the cosmos? Would it even be possible to communicate with them? The notion of an interplanetary meeting represents both a profound aspiration and a formidable challenge. Human history is rich with encounters between disparate cultures, each of which offered valuable lessons and led to deep transformations. What might we possibly learn from an alien civilization? Furthermore, the search for life beyond our world encourages us to consider the conservation of our own planet. Earth is a precious oasis in the immense desert of space, and the importance of caring for it grows with each passing day. If life proves to be a rarity in the universe, then we have a solemn duty to do everything in our power to safeguard what we possess. Therefore, as we pursue these cosmic answers, we must also act with responsibility. As we forge ahead in this great search, the future appears incredibly bright. Space missions persistently unveil new secrets and broaden the scope of our knowledge. Technology is advancing with astonishing speed, enabling us to explore more distant reaches of space than we ever conceived of. With every fresh discovery, we draw nearer to resolving the question that has captivated humanity for centuries. Are we alone in the universe? The journey toward comprehending the cosmos is filled with marvels and unexpected turns. The search for life on other worlds is merely one element of this spectacular odyssey. So, the next time you gaze up at the stars, remember that every question we pose and every answer we uncover brings us closer, not only to understanding our place in the universe, but also to grasping the very essence of life itself. Ultimately, the quest for extraterrestrial life is not just a scientific endeavor. It is also a matter of hope. The possibility of other beings with their own unique stories and perspectives inspires us to dream bigger and to continue exploring. With each new finding, it's worth recalling that the cosmos is a vast ocean of mysteries, just waiting for us to discover them. The adventure is only just starting, and the universe has so much more to reveal. What could a vinyl record, a message sealed in a bottle, and a voyage to the stratosphere all share? Each represents an effort to communicate, a fundamental search for connection. Within the immense and enigmatic universe, the Voyager probes have served as our emissaries, transmitting our stories and scientific data from the frontiers of the solar system. These spacecraft, which began their journey in 1977, are far more than mere machines. They are time capsules, carrying a fragment of humanity into the great unknown. The Voyager mission was born from the bold ambition to explore the outer planets of our solar system. Can you envision a journey of such immense duration, guiding you through the splendor of Jupiter's tempests, past the rings of Saturn, and even farther? The Voyager probes gave us a glimpse into worlds that had previously existed only in our imaginations, unveiling their breathtaking details. The storms on Jupiter, for instance, are so colossal they could completely swallow our own planet. Just try to imagine a storm of such incredible power that it forces you to reconsider the very scale of Earth. However, the Voyager probes were explorers, not just passive observers. With every single photograph and measurement, they gathered indispensable data on the composition and dynamics of these distant planets. As Voyager 1 drew near Saturn, its cameras captured images that exposed a world brimming with wonders. The rings, those elegant filaments of ice and dust, transformed into a spectacle that astounded both scientists and the public alike. Who could have foreseen that these rings would be so intricate and lovely, resembling a masterpiece of art in perpetual motion? As the probes journeyed onward, they also started to push past the very limits of our solar system. In 1987, Voyager 1 achieved the distinction of being the first human-made object to enter interstellar space. What does that truly signify? Imagine you are on a ship in the vast ocean and suddenly become aware that you've sailed far beyond any known coastline. The Voyager probes are that ship, navigating uncharted territory and sending back information that helps us understand not only our solar system, but also the vast universe that envelops it. As the probes ventured deeper into the void, they carried a special message with them: the renowned Golden Record. This record, which functions as a sort of time capsule, is an attempt to communicate the core of humanity to any life form that might one day find it. Can you picture yourself as an alien being who stumbles upon a golden disk floating in space? The record holds greetings in more than 100 languages, a selection of music from across the globe, and a gallery of images that reflect the diversity of our species. It is like a family photo album, but on a cosmic scale. The voyage of these probes has been anything but simple. Over the decades, the unforgiving conditions of space have started to take a toll on their systems. And yet, despite these immense challenges, the probes continue to transmit data. Every signal we pick up is a testament to their incredible durability and to the human ingenuity that brought them into existence. How much longer do you suppose they can keep sending back signals? They are projected to continue their transmissions for several more years until their power sources are finally exhausted.
It serves as a powerful reminder that even as these probes journey into the vastness, they remain tethered to us here on Earth. The Voyagers have also become our teachers, instructing us about the environment they navigate by studying solar wind, magnetic fields, and cosmic radiation. This has given us crucial insights into the interaction between our solar system and the space between stars. Did you realize that space is far from a vacuum? It's a cosmic sea teeming with particles and energy, and these probes have shown us how to chart a course through it. The saga of the Voyager probes is also a powerful lesson in human perseverance. In the beginning, the mission's viability was questioned by many, but through the dedicated work of thousands of scientists and engineers, an incredible triumph was born that has endured for decades. Every new piece of data broadened our cosmic horizons and ignited the imagination of an entire generation. Isn't it astounding to consider how a small team of engineers could fundamentally alter our view of the universe? A truly remarkable quality of the Voyager mission is its power to bring humanity together. Your origins and personal history don't matter, because we all possess a fundamental curiosity about the cosmos. The probes serve as a profound symbol that, for all our divisions, we are united by a shared purpose: to explore and comprehend the universe we inhabit. As I speak, Voyager 1 is more than 20 billion kilometers from our planet. It has undertaken a long and solitary voyage, yet its legacy continues to thrive. Each time we receive its faint signals, we're reminded that we are connected to something immeasurably larger than ourselves. What other secrets will it uncover on its endless journey? We can only wait for time to reveal the answers. So the next time your gaze turns to the star-filled night sky, I want you to think of the Voyager probes. They stand as a testament to our innate curiosity and our relentless drive to venture into the unknown. They have demonstrated that while the universe is immense and enigmatic, there is always something new waiting to be found. And perhaps that very fact is what makes our own existence so profoundly special. The path blazed by the Voyager probes is one that most of us can only dream of traveling. Their story, however, is far from over. Every new finding they transmit moves us closer to solving the riddles that have captivated humanity since the dawn of time. What exists beyond the edge of our knowledge? What mysteries are still hidden in the boundless theater of space? When you reflect on their epic journey, you are reminded that the act of exploration is perpetual. Each step forward in science and technology unlocks new possibilities, and every question we answer leads us to new inquiries. With this in mind, let us press on to explore, to learn, and to dream, because the cosmos is brimming with wonders yet to be unveiled. The magnificent universe presents an unforgettable panorama, a tapestry of mysteries and marvels that compels you to contemplate your own existence. Every star, every galaxy, and every tiny speck of cosmic dust has a story to tell. But what is the deeper significance of all this for you and me? What is our true position within this immense cosmic design? The sheer scale of the universe can certainly be daunting, and at times you might feel utterly insignificant in the face of its vastness. And yet, you are a direct product of this very cosmos, composed of the exact same elements found in stars and planets. Isn't it a captivating thought that a fragment of the universe's history resides within each of us? We are, quite literally, stardust, a fact that connects us deeply to everything that exists. It is human curiosity, that inherent spark compelling us to explore the unknown, that has driven generations to look up at the sky and ask, what is out there? Yet how many definitive answers have we actually secured? This pursuit of knowledge is a never-ending odyssey, where each new discovery simply opens up more questions, resembling a labyrinth where every turn reveals new avenues to investigate. Science has equipped us with incredible instruments to decipher these cosmic puzzles, from telescopes that peer into the deepest reaches of space to probes that venture beyond our own solar system. We are constantly pushing the limits of our understanding. Still, for every answer we find, a host of new questions emerges. For instance, when we identify an exoplanet capable of supporting life, we immediately wonder what forms that life might take and if we could ever communicate with beings from another world.
The splendor of the cosmos is found not just in its scale, but also in its intricate complexity. Imagine the graceful dance of the planets in their orbits, each following a distinct course in a perfectly synchronized celestial ballet. This delicate equilibrium is maintained by gravity, the invisible force that binds all celestial objects. But you then must ask, what occurs when this balance is broken, leading to galaxy collisions and the birth of black holes? Some of the most fascinating results of this cosmic interplay. As you delve deeper into the universe, you also come across concepts that challenge your intuition. Dark matter and dark energy represent two of the greatest enigmas we have yet to solve. What exactly are they, and how do they shape the very structure of the cosmos? Although they remain invisible to us, their effects are unmistakable. In this way, science resembles a colossal jigsaw puzzle with many pieces still missing. But with every discovery, the final image grows clearer, bringing us closer to understanding our place within it all. The expansion of the universe, for instance, serves as a constant reminder that nothing is static. Everything is in perpetual motion. Picture a balloon being inflated. As it grows, points drawn on its surface steadily move apart from one another. Our universe behaves in a similar fashion. This leads to profound questions that will captivate humanity for ages to come. What is it expanding into? And does this expansion have an ultimate limit? The expansion of the universe, for instance, serves as a constant reminder that nothing is static. Everything is in perpetual motion. Picture a balloon being inflated. As it grows, points drawn on its surface steadily move apart from one another. Our universe behaves in a similar fashion. This leads to profound questions that will captivate humanity for ages to come. What is it expanding into? And does this expansion have an ultimate limit? The expansion of the universe, for instance, serves as a constant reminder that nothing is static. Everything is in perpetual motion. Picture a balloon being inflated. As it grows, points drawn on its surface steadily move apart from one another. Our universe behaves in a similar fashion. This leads to profound questions that will captivate humanity for ages to come. What is it expanding into? And does this expansion have an ultimate limit? The search for life on other worlds also occupies a central role in our quest for understanding. Are you and I truly alone in this immense universe? The very notion that other life forms, perhaps even intelligent ones, could exist fills us with a sense of wonder. The exploration of exoplanets has uncovered worlds that challenge our wildest imaginations. Some resemble Earth, while others are utterly alien. The possibility of intelligent alien life makes you wonder what a conversation with them might even be like as we continue missions that push our knowledge far beyond the confines of our solar system. Consider the Voyager probes, which have acted as our emissaries in the boundless expanse of space. Each piece of information they relay serves as a powerful testament to the limitless nature of human curiosity and confirms that the impulse to explore is an intrinsic part of who you are. As we near the conclusion of this particular journey, it's crucial for you to recognize that our comprehension of the cosmos
is merely in its initial stages. Science is progressing at an incredible pace, with new discoveries and theories emerging constantly, compelling you to rethink everything you thought you knew. The cosmic tale is a continuously unfolding saga, and you play a vital role within it. The sheer scale and magnificence of the universe is an open invitation for you to persist in dreaming, to continue your explorations, and to never cease asking questions. While you may never uncover all the answers, it is the very process of questioning and the relentless search for knowledge that truly defines your humanity. Every star that shines in the night sky is a reminder that no matter how vast and mystifying the universe seems, your curiosity and desire to understand must never wane. Exploring the cosmos is an eternal voyage, an adventure that goes beyond the confines of time and space. And as you continue to look to the heavens, new revelations will always await. The story of the universe and your connection to it is far from finished. So keep your eyes raised and your mind open, because the greatest discoveries are still to come. Let's move forward.